Okay, let's try another example. So again, here is another non-homogeneous second order linear differential equation. And notice, right, our f of x, right, our function of x here is a linear function, right? I mean, the slope is 2, our y-intercept is 3. So let's, again, step 1. So here we want to find our y sub c, right? Again, that's general solution to the homogeneous equation. So we have our y double prime minus 5y plus 6 equals 0, right? That's our homogeneous equation. And there's an associated characteristic equation that is r squared minus, and I'm missing a prime right there, minus 5r plus 6 equals 0, right? So again, we're using our characteristic equation. And again, this is all just factoring techniques. So if we factor this polynomial, right, where r is our root or r0, we should get, let's see, it says r minus 3 and r minus 2, right? If we FOIL that, we get our polynomial above, and of course this is r equals 3 or r equals 2. So notice we get two distinct real roots, and our y sub c, or y sub c of x, right, our homogeneous, our general solution to this homogeneous equation is c1, right? It's the linear combination of, so we have c1 e to the, in this case it's 3x plus c2 e to the 2x, right? It's a linear combination of both exponential functions, e to the 3x and e to the 2x. So we have one guy, right? So now step 2, again, we want to construct a particular solution, so a y sub p, again, to the non-homogeneous equation, right? Again, we've been finding our y sub p to our homogeneous equation, but now this is non-homogeneous. And again, we base our choice on a specific form. So our y sub p, right, what was our f of x? Well, the form was linear, right? I think last time I did it, I think I did purple, right? This is my f of x, so it's a linear function, right? mx plus b or ax plus b. So I'm going to use, I'm going to pick ax plus b. And of course, if we differentiate a linear expression, this is nice. This is just a. And yp double prime, well, derivative of a constant is just 0. Okay, so let's go ahead and substitute these expressions back into our original, right, our non-homogeneous equation. So I'm going to go ahead and write it out again. Y double prime minus 5y prime plus 6y equals our function of x. All right, again, it's our new part, our f of x. And again, so y sub, well, this is really nice, y sub p of double prime, that's just going to be 0, which is nice, minus 5y prime, well, that's just a, plus 6y, where, again, we're guessing our y sub p, so that's 6 times ax plus b. Okay, so remember our our first example, this guy was an exponential function. This is obviously not an exponential function, right? It's a linear function, right? It's actually, let's see, the y-intercept is 3, right? The slope is 2, so, right, again, this is just a sketch. So notice, I mean, here's our x-axis. Our linear function, right, it could be 0, right? Our exponential function, right, that was like this, that could never touch the x-axis, but in this case it can, so we can't just divide by, 2x like we did with e to the 2x, which was one of the options. So again, let's just simplify this guy. Well, 0 is just 0. Minus 5a, I'm distributing 6ax, that's a plus 6b equals 2x plus 3, and we can combine our constants, right? That is, well, we can write it as 6b minus 5a, or negative 5a plus 6b, same thing. Plus 6ax equals 2x plus 3. So again, the reason I rearranged my constants and my x's is because, I mean, we're going to equate coefficients. So this guy, right, this is our, okay, this has an x in front of it. Well, this has an x in front of it. So that means 6a must be equal to 2. Maybe let's write that in green, right? So, well, I want to write some extra steps, but I'll just go ahead and imply. So again, I know that those are the coefficients, right? X is equal to x, so 6a must be equal to 2. Well, that just means a is a third. Okay, so we found our a. We still need our b. But, I mean, this is just a constant, right? Well, this is just a constant, right? There's no x in front of it. So, I mean, if this expression, right, if this expression is equal to this expression, well, I mean, these are equal because, again, there's no coefficient. There's no x in that case. Hopefully that makes sense. This is a lot of kind of algebra rules or strategies. So we have 6b minus 5a equals 3. And, I mean, this is really just a system of linear equations. So, I mean, you can think about it like this, right? But we already found a, so, I mean, we can just substitute it back. So we have 6b minus, okay, 5, well, it's just going to be 5/3. Equals 3, and again, we're just solving a fun algebraic equation. Let's see, I can multiply everything by 3. So I get 18b minus 5 equals 9. 18b equals 14, right? And eventually 14/18. 2 times 7, 2 times 9. So our b is equal to 7/9. So the method of undetermined coefficients, well, there are my coefficients, right? We found our coefficients. And so now let's just put everything together, right? Y, again, solution, general solution to the non-homogeneous equation. So we have y sub c plus y sub p. Well, our y sub c was, what was our y sub c? It was our yellow. Okay, so 2x, 3x, right? That was our yellow guy. So c1 e to the 3x plus c2 e to the 2x, that's an x, plus our new guy. What was our new guy? Our y sub p was, I don't know if I used green or not. Did I use green or not? Any green? Okay, no green. Just don't want to confuse you. So here's our y sub p, right? It was ax plus b, but I just found ax plus b, or I found a and b. So a is, what was a? I already forgot. A is a third. So 1/3, right? There's your ax plus b plus 7/9. Okay, so that is our general solution, again, to the again, let's just write it out, it doesn't hurt. General solution to non-homogeneous equation. And again, they don't give us initial conditions, so we don't know what C1 and C2 are in this case. So that's it. Again, hopefully that makes sense, and I will do a couple more.